Hi, everybody. Kind of continuing on with the 6-2 part 2 now. So let's say we have this equation, and now we're trying to solve on this interval from 0 degrees to 360 degrees. So we're in degrees now, and I want to solve this equation. It's already factored for us. So really, we just go straight to the step of kind of writing this out. Cotangent theta minus root 3 could be 0, or 2 sine theta plus root 3 could be 0. Okay, so if I solve this guy, I could get cotangent theta is equal to root 3, or this guy I can get 2 sine theta is equal to negative root 3, which means that the sine of theta is negative root 3 over 2. Okay, now, a couple different ways to think about this. So I could literally think about when is the cotangent going to be root 3, or I could think about the tangent. Now, it doesn't really matter which way you think about it. Tangent, of course, is 1 over root 3, which is really just root 3 over 3 if I rationalize it. So either way, I'm going to come up with the same angle. So let me illustrate. Let's think about this. So really, I actually claim it might be easier to think about cotangent here. Because what am I really looking for? I'm looking for what's going to give me a root 3 over 1 ratio, what angles, okay? And my claim would be that that's going to happen in a couple different places here. And one place is going to be, let's say, right. Actually, I wrote that backwards. Sorry, I had it thinking about it. 30 degrees, which is right here, and that is at root 3 over 2 comma 1/2. So if I look at that 30 degree angle right there, okay? And that's because if I look at the cotangent of 30 degrees, make sure that we're in the, okay. Write that a little bit over. Oh, the unit circle's okay. Actually, let me just move this just a little bit just in case. Okay, but the cotangent of 30 degrees is really x over y. Like tangent was y over x, cotangent is x over y. So if I do root 3 over 2 divided by 1/2, right, that's really our root 3. So 30 degrees is one place. If I look at the tangent of 30 degrees, right, that's going to give me 1/2 divided by root 3 over 2. That's going to give me 1 over root 3 or root 3 over 3. So either way I think about it, I get 30 degrees is 1. What's another angle that does that? So another angle that would actually do that would be down here. And that's going to be at negative root 3 over 2, comma, negative 1/2. That angle is going to be 210 degrees. So there's a little kind of fact that I casually mentioned. I think I remember saying the sine and cosine had periods of 2 pi. So really we're seeing all those values cycle through. Tangent has period of pi. So if I know that, say the tangent of 30 degrees is root 3 over 3, if I look at an angle 180 degrees past that, say 210 degrees, the tangent of 210 degrees is also root 3 over 3, okay? It has a period of pi. Don't necessarily need to know that to do this question. Really, I think if you think about it, it's going to boil down to the angles with the root 3. You're just thinking about the two that are actually going to give you what you want, which are going to be 30 degrees and 210 degrees, would solve this equation, okay? Either way you slice it. So theta is 30 degrees, 210 degrees, okay? And so that solves that one. This is the same as that as I talked about, okay? Sine theta is equal to negative root 3 over 2. So when is that going to happen? So it looks like that happens here, and so that would be at 4 pi over 3, right? Negative 1/2, negative root 3 over 2. And the other angle that gives you a sine of negative root 3 over 2. That would be a 5 pi over 3. That's a 1/2 negative root 3 over 2. So two places that give a sine and negative root 3 over 2 are, and I want that in degrees, not radians. Sorry. Like I said, I think in degrees. This is 240 and this one is 300. Sorry, degrees. So I want to give the answer in degrees. Good thing I wrote that because to remind you, don't write the answer in radians if I'm asked for, the answer in that interval with degrees. I'm looking for degree answers. So this I've got 240 degrees and 300 degrees. Okay, and that solves this. So this equation has 4 solutions. Okay, let's look at another one. All right, let's take a look at 31 here. 2 tangent squared theta sine theta minus tangent squared theta is equal to 0. Okay. I think from here on in, I'm going to just kind of get the equations for you, and I'm going to have you verify what the answers are in degrees. So kind of going to do that front work of looking at the unit circle and kind of verifying what I'm going to tell you here. Okay, that'll be good practice for you in the video. Okay, but as far as what we need to do algebraically to solve this, our first step is going to be to factor out, say, a tan squared out of this left-hand side. So we factor out our GCF. Again, I don't want to divide by that because I might be losing some solutions if I do. But I've got these 2 equations now. Tangent squared theta could be 0, or 2 sine theta minus 1 could be 0. And if I solve this equation, I would take the square root. So here, there's no plus or minus 0. It's just tan theta equals 0. And here, sine theta is 1/2. Okay. So pause it. I want you to think about when the tangent's going to be 0. When is the sine going to be 1/2 on this interval? And I'll write down what they are here. So you got 60 degrees. Sorry, not 60. Sorry, 30 degrees. And you got 150 degrees. That would solve this one. What is going to solve when the tangent is 0? Well, that is going to be, let me just scroll that up. When is y over x 0? Well, that's a little tricky. So there's 2 places, right? Here, the tangent of, say, 0 degrees is, say, y over x is 0 over 1, right? That's 0. So 0 degrees works. Another angle that works is 180 degrees because tangent of 180 degrees is 0 over negative 1, y over x, and that works. So I got 0 degrees and 180 degrees. Would it be okay if I wrote 360? Because that is also, tangent of 360 degrees is also 0. But it wouldn't be okay with the interval, right? So remember that I'm looking for an angle between 0 degrees and 360. So it can include 0 but not 360. So wouldn't want to see that 360 even though it does solve that equation because it's not in the interval that I want my solution on. And those would be my 4 solutions there. Okay. So kind of looking at another problem here. Let us look at number 33. Okay, so secant squared theta, tangent theta is equal to 2 tangent theta. Okay, so there are a couple places where we could get led astray with this one. So let me first point out that before there was kind of just one trig function, right? Well, there might be multiple, but I could set those, factor them and then set them equal, and I could go through and solve it, right? Now, if I try to do that with this one, can I do that? So I set it equal to 0. Can I actually factor this? Yeah. I mean, I could still pull out a tangent theta, right? So that I've got tangent theta times secant squared minus 2. Okay, now, I'll show you both ways. I'm not sure which way you're more comfortable with. The first thing is that, yes, this looks good to me. I've got the tangent theta is equal to 0. The other thing that you can do, and if you're saying this isn't a difference of perfect squares, you're kind of right. It's not over the integers. It's not a difference of perfect squares. I mean, what I could do is I could take this equation, this secant squared theta minus 2, and I could set it equal to 0 like that. And I could add 2, and I could take the square root. So when I do that, I get secant theta, and this has got to be plus or minus root 2. There are possibilities. Now, I wouldn't want to look at it like that. I would actually want to think about it as cosine theta, so the reciprocal, instead of thinking about it as secant. Cosine theta would be the reciprocal of this, plus or minus 1 over root 2. Of course, if I really rationalize that, that's cosine theta is equal to plus or minus root 2 over 2. Okay. So, and then I also have tangent theta could be 0 from this equation. All right. Now, the other way is you could continue to factor this. So if I did tangent theta, secant squared minus 2, you could factor that as secant theta minus root 2, secant theta plus root 2, and then set those equal to 0, and you're basically doing the same thing that you had here. Does it matter which way you think about it? No, it does not. Bottom line is we're going to get to something like this. When's tangent 0? When's cosine root 2 over 2 or negative root 2 over 2 on that interval? Okay. So why don't you take a second and write down what you think that's going to be. Okay. So tangent is going to be 0. So kind of thought that was 0 degrees and 180 degrees again. And then root 2 over 2 or negative root 2 over 2, that's going to be a lot of the pi over 4 angles. But it's not pi. See, you're always in radians, not degrees. That's why. 45 degrees, right? And the other ones are 135 degrees, 225 degrees. What's the other one? 315. So I'm talking about those places because those are my places where, so at 45 degrees, I've got root 2 over 2, right? Cosine of 45 is root 2 over 2. And then I've got these other 4 places here at 135, 225, and 315. where I have that same thing happening. So where I've got, here I've got negative root 2 over 2. Here I've got negative root 2 over 2. Here I've got root 2 over 2. Right, so on. Okay, so these latter four solve this equation, and these first two solve the tangent theta equals 0. So all in all, you actually have 6 solutions to that equation. It's fairly fruitful. That's kind of nice, right? So what was that one, 33? Yeah, I think I also want to do... No, that's not too bad. Let's also do 39. Last one for this video. Okay, so for 39. So for this one, we've got sine squared minus 2 sine theta plus 3. And we want to solve this one. Okay. So what numbers multiply to 3 and add to negative 2? So I don't think any. So you can't factor. What do you do? How do you know that there's not a solution? I want to compare this to something like x squared minus 2x plus 3. So if I had equal to 0, and if I had this equation, I wouldn't hesitate to, if I couldn't factor it, use the quadratic on it. So negative b plus or minus our radical b squared minus 4ac, right? So just plug it into that quadratic formula, and I would notice that the discriminant is 4 minus 12, that's negative 8, right? So that would be BOD, right? That would be complex numbered solutions, okay? And I can do the same thing with the sine of theta. So this is going to be, it's quadratic in sine theta instead of x. So sine theta would be like minus b, so it would be a 2 plus or minus radical b squared minus 4ac. And what I notice is that the sine of theta would be equal to some complex number, okay? That's not possible for real numbered input, okay? I won't say complex numbered, okay? Wait till grad school, all right? But we got this right here, all right? This is no solution to this, okay? In fact, it's saying no solution, or I could say, my empty set, either one. Because this is not a real number here. The sine can't be a complex number. Sine of theta can't be a complex number for a real number input. So this one has no solutions. All right. Hopefully that's good. I think you'll have a lot of fun going through these. These are always some of my favorite ones to do. So